Zeki needs to answer a phone call. I will mute just 1 second.
Okay, it's okay. It's okay.
Right, sorry about that. We're back. Hello.
It's okay. Hello. I hope your health is well.
Yeah, we're happy. We're happy. We're very pleased to see you. Hello.
We're really excited to make this event with you. We are really excited to share your knowledge and wisdom. We will start our presentation after 5 minutes. Now we are waiting to participants to attend.
Okay.
Is this
Okay.
okay for you?
Yeah.
Should we call you back?
No, no, no.
We can just wait. Yeah.
I will just close my microphone camera, then I will turn back or come
Okay.
back. Thank you very much for your understanding.
Mm,
Alo. Hı? Hı hı.
Um, Good evening, everyone, and I'm so sorry for the delay. Ladies and gentlemen, and fellow enthusiasts of the human mind, my name is İpek Köker. I'm a second year medical student at Ankara University. And also, I am also honored to serve as the head of the scientific team in our student community, Ankara University Neuroscience Community. We have been running a presentation series on our YouTube channel called Ankara Üniversitesi'nin Bilim Topluluğu. This series covers a wide range of topics related to neuroscience. And today we are truly honored and excited to welcome you all and want to thank you all for attending our presentation featuring Professor Semir Zeki and Samuel Rasche. We want to thank them for being here with us today. We are privileged to have them here, and we are really excited to share their knowledge and insights. Before the presentation, I would like to briefly introduce Semir Zeki. Professor Semir Zeki is one of the foremost neurobiologists of his generation. He obtained his PhD in anatomy from University College in London, followed by postdoctoral research in the United States. Over the next 3 decades, he pursued a distinguished career in neurobiology, and he is currently professor of neurobiology at UCL. Zeki is a fellow of the prestigious Royal Society, a foreign member of the American Philosophical Society, fellow of the Academy of Medical Sciences, and member of the European Academy of Sciences and Arts and Academia Europaea. He is also a member of the Scientific Board of Governors at the Scripps Research Institute and former director at the Wellcome Laboratory of Neurobiology at UCL between 1994 and 2001. Professor Zeki's lifetime contributions are centered on the organization of the visual cortex in humans and other primates. One of his earlier keynote findings was the discovery that specific areas of the visual cortex engage in segregated responses to either color vision or visual motion stimulation, and that color and visual motion are perceived at different times. He described how colors are represented in the visual cortex and how that region uses color-coded cells to process color images. From the wealth of information that he gathered over several years on vision and motion pathways, Zeki formulated an overall theory of visual consciousness in which he proposed that the visual brain contains several parallel and functionally specialized processing areas. Subsequently, he developed a novel psychophysical technique which showed that the cortical regions processing a visual stimulus are also involved in its perception. This cutting-edge discovery provided the basis for his revolutionary concept that consciousness is not a unity but an assembly of numerous micro-consciousnesses distributed both in time and space. He's studying how these visual micro-consciousnesses are integrated to produce a unified perception of the visual scene. In addition to the King International Prize for Science, Professor Zeki's seminal contributions to the biology of vision were recognized by numerous other prizes, invited lectureships, membership of learned societies, and editorial boards. He authored or co-authored 180 papers and 4 books. His main interest outside his work is in learning more about art and creativity as manifestation of brain activity, and this has led him to engage with artists and write about their work. Professor Semir Zeki has been awarded the prize for his seminal work on the organization of the visual brain. And I want to also encourage you all to embrace this amazing opportunity to ask questions to Semir Zeki and Samuel Rasche by filling the form. We are truly honored to have you here today. Without further ado, I close my microphone and yield the floor to Semir Zeki and Samuel Rasche.
All right, thank you very much. I will start by sharing the screen. Here we go. Okay, let's see, are we... Okay.
Well, thank you very much for your very nice introduction, very comprehensive introduction. It's a great honor and a great pleasure to be with you in Ankara, though unfortunately not with you in person, because I like visiting Turkey very much, and you'll be surprised perhaps to learn that between the year 2000 and the year 2013, I went to Turkey every year. And even tried to learn Turkish, which is a very difficult language for me to learn. Now, I want to talk to you today not about functional specialization in the visual brain and nor about multiple consciousnesses, but I'd like to talk to you about the science of beauty. This is an extremely interesting topic, if only because each one of us can experience beauty and each one of us seeks beauty. Whatever our cultural belongings or ethnic group, we all seek beauty. But none of us can really define what beauty really is. And when science approaches the question of beauty, it does not do so in the same frame of mind as the humanities. In the humanities, they ask, what is beauty? And they've been asking this for 2,500 years without an adequate resolution, without an adequate answer. So science asks a different question, which is much more scientifically amenable. Science asks the question, what are the neural mechanisms that are engaged when we experience beauty? This question is as scientifically legitimate as the question of what are the neural mechanisms engaged when we perceive faces or when we perceive colors. But even though the question itself is much more restricted than the broad question that the philosophers of aesthetics and art historians ask, our question is nevertheless inspired by the discussions in the humanities and in the arts, which have been going on for 2,500 years. How could it be otherwise? They have been discussing this topic for so long, and they've got so many insights, and some of these insights were bound to attract the attention of scientists. And it turns out that one of the greatest insights was, or rather scientifically amenable questions, was provided by, not by a scientist, but by an art critic, Clive Bell. Clive Bell was a very well-known art critic in the early part of the last century. He was the husband of Vanessa Bell, who's better known as a painter. She is better known than him. But Clive Bell asked the following question. He said, what do all things which we experience as beautiful have in common? Now, this is an extremely interesting question. He's looking for the common factor in all that we experience as beautiful. And he said, if you can solve that problem, if you can tell me what is the common factor in all that we experience as beautiful, then you have essentially solved the problem of aesthetics. Now, artists and art historians and philosophers of aesthetics never have, but we can use that question in a different, slightly different frame and ask the following question. What is common in terms of neural mechanisms that are active in the brain when we experience different kinds of beauty? So what is common to all beautiful experiences, all beautiful aesthetic experiences? Clive Bell asked the question in the following context. He said, if you can tell me what is common to the following, the Center Sophia, the Hagia Sophia in Istanbul, and the windows at Chartres Cathedral, a Mexican sculpture, a Chinese Tang Dynasty bowl, Persian carpets, the frescoes of Giotto at Padua, and the masterpieces of Poussin, Piero della Francesca, and Cézanne. If you can tell me what is common to all these different works of art, you have essentially solved the problem of aesthetics. Now, notice that Clive Bell has used only visual examples, although he did, in fact, mention very briefly in a passing sentence or two the beauty of music or mathematics. Notice too that he was looking at different portraits and different sort of kinds of beauty, and there was no example from music and other sources of beauty. So we wanted to do it slightly differently. We wanted to include musical beauty and other kinds of beauty because the question we're addressing is what is common to, in terms of neural mechanisms that are engaged whenever we experience a beauty, regardless of its source. Now, you will also notice that, you will not notice, but I'm telling you that Clive Bell said that if you want to ask about aesthetic emotions or beauty, you never ask an art historian or an art critic because they know too much. Instead,
I'm really sorry for interrupting you, but we can't see your screen. We can only see a black
yeah, it is blank.
screen.
It is
It is
blank
blank
at
right
the
now?
moment. It is blank
Okay.
because I wanted you to concentrate on what I have to say before I go to the.
Yeah, I'm really sorry. I thought there was a technical problem.
No. It's purposely blank. He said you never ask an artist or an art critic because they know too much. Instead, you want to ask ignorant people and savages and children because they can also experience beauty, and they can tell you about their experience of beauty uncontaminated by specific cultural environments. So what we did was to take people from all ethnic and cultural backgrounds and ask them to come and look at various paintings and listen to various musical excerpts. And we excluded any student or any person who was studying music or painting or had knowledge of art or art history for the obvious reason that they know too much. And they came to the lab and looked at paintings and listened to musical excerpts and rated them according to how beautiful they experienced them to be. And I'm going to show examples of things of paintings which they thought were very beautiful. For example, this coming one was the Odalisque by Ingres, was thought by most, not all, but by most, to be a very beautiful painting. Whereas the next one, which is by Lucian Freud, is called The Benefit Supervisor Taking a Nap, was considered by most to be very ugly. Now you can see that why you exclude artists and painters, because this is a magnificent painting. It depicts the passage of time and corpulence and bodily decay. And if it were to come up for sale, it will no doubt fetch millions of pounds. But the important thing from our experimental point of view is that none of the people who were looking at this and rating it thought of it as beautiful. With musical excerpts, I don't know how well the sound will carry across Zoom. I don't have much faith in it, but anyway, this is next excerpt which they listened to, which they all thought was very ugly, is the second movement of Ligeti's violin concerto. Now, again, a musician with good knowledge of music might find great musical qualities in this piece, but the important thing from the experimental point of view is that those who listened to it did not find it beautiful. Uh, Whereas the next piece, the Adagietto from Mahler's Fifth Symphony, was found to be very beautiful by everybody.
Unfortunately, we can't hear the symphony.
Now, these are not the only musical excerpts or the painting that they experienced. They, of course, rated many, but there were enough examples of very beautiful and not beautiful paintings for us to be able to decide what brain areas are engaged when people experience something beautiful derived from musical or visual sources. Now, if you just compare what happens in the brain when they look at something, you find that the posterior part of the brain, the visual brain here, is active. Let me just say, I'm terribly sorry, I say how this is done. For anyone who does not know, what happens is that people come into the scanner and rate these paintings again, and while they're rating them again, according to how beautiful they experience them to be, we determine which areas in the brain are active. And we do this by looking at the changes in blood flow in the brain. Because when cells in an area of the brain are especially active, the um, their metabolic requirement increases, so more blood is channeled to that area. And there is a difference between the magnetic properties of oxygenated and deoxygenated blood, which the cameras around the brain can capture. And thereby we can localize the activity in the brain, and equally importantly, we can determine the strength of the activity. So that is the method that's used. And if you look at the brains, if you compare what happens to their brain when they're just looking or when they're just listening, you find that with just looking, it's the visual areas here which are active, and with listening, it's the auditory cortex here which is active. But if you ask the question, what are the areas of the brain which are active when the subjects experience a visual stimulus, a painting as beautiful, you find that in addition to the visual areas, there's an area here which I want especially to draw to your attention, this one here, which is the medial orbitofrontal cortex, field A1 of the medial orbitofrontal cortex. And if you ask what are the areas of the brain which are engaged when people experience musical beauty, you find the same area, and this time now shown in green, is active here. And the conjunction of the two is shown in yellow. So, to a first approximation, we have answered the question raised by Clive Bell. What is common to the experience of beauty derived from musical and visual sources? And the answer is that there is a unique area located in the frontal lobes, field A1 of the medial orbitofrontal cortex, shown here in yellow. Now, of course, there are many other sources of beauty. For example, there is a question of beauty from sorrow and from joy. And in this case, what you do is you get people into the lab and you show them pictures which are sorrowful, some of which are very beautiful, others less so. And you show them also pictures which are joyful, some of them are very beautiful and others less so. According, each individual decides what's beautiful and what's not beautiful for themselves. And an example of a picture that most people, in fact, all of them found to be very beautiful, and also very sorrowful, is the iconic picture of Dorothea Lange during the Depression in the United States in the 1930s. A mother with two children who is facing defeat, really, and misery. It's a very magnificent picture. It's an iconic picture. And most people found this to be extremely sorrowful, but also extremely beautiful. Whereas, by contrast, the next picture of the young girls in the East End of London dancing during the war by Bill Brandt, it was considered by most people to be a joyful picture and also a very beautiful picture. Now, if you ask what are the areas that are active when you experience beauty derived from joy and from sorrow, again, the experiment conducted in the same way, you find that there is one area, this time looked at from below. It's the same area, the medial orbital frontal cortex of the brain, which is active. So we have now taken Clive Bell's question a step further and have determined that musical, visual, sorrowful, and joyful beauty, or rather, beauty derived from musical or visual sources, or from sorrowful or joyful sources, all have this thing in common, that they correlate with activity in the same part of the brain, which is field A1 of the medial orbital frontal cortex. Now, the ancient Greeks, had a single word, kalon, to signify both moral and physical beauty. And a very good example, which is given of that, is the Westmacott Youth, which is at the British Museum now, of a young athlete with a very beautiful physique, but with a downturned head, which signifies his humility and modesty after winning in an athletic game. So the way in which you conduct an experiment on moral beauty is, for example, and these are experiments done in the United States by Tsukura and Capezza, not by us. You ask questions such as, if you are hungry and you have the opportunity of having a meal, do you have the meal yourself, a good steak, or do you give it to a hungry child? The latter is, of course, morally a higher ground than the former. And it is questions like these that people are asked in the scanner and the activity in their brain monitored. And it turns out that when you ask questions like the ones I've just told you, the activity again occurs in the medial orbital frontal cortex here. It's a bit more posterior, but you can now extend Clive Bell's question further and say that moral beauty, visual beauty, joyful beauty, sorrowful beauty, musical beauty, all correlate with activity in the same part of the medial orbital frontal cortex of the brain. Therefore, we have, to a good approximation, solved the problem of aesthetics, but only in a neurobiological context, because remind you that Clive Bell said, if you can tell me what all things which you experience beautiful have in common, you have essentially solved the problem of aesthetics. Well, I'm trying to say that you can give a positive answer to that question within neurobiology, although I'm not sure we can do it outside neurobiology. So we'd say that in terms of neurobiology, all things that are experienced as beautiful have this thing in common, that they correlate with activity in the medial orbital frontal cortex of the brain. Now, it turns out that these experiences are not just localizable, but they're quantifiable. I was once giving a lecture in Chicago, and a rather well-meaning young man said to me, but Professor, science is about measurement. You are telling us about aesthetic beauty, about aesthetic experiences. And his question was justified and right, but it was only half right, and therefore it was wrong, because science is not about quantification. Science is about satisfying curiosity. And measurement is one way of satisfying that curiosity, because it has got the attribute of predictability. But as it happens, you can quantify the intensity of activity in the medial orbital frontal cortex in relationship to the declared intensity of the experience of beauty. In other words, you can ask, if someone finds A more beautiful than B, is the activity in the medial orbital frontal cortex, as judged by cerebral blood flow, more intense than when the person judges something to be very beautiful and when they judge it not to be very beautiful? And the answer is a definite positive. So here's the medial orbital frontal cortex shown in yellow here. And if you look at in the activity, you find that with very beautiful stimuli, the blood flow there is oh dear. I'm sorry about that. The activity there is higher with very beautiful stimuli than with ugly stimuli. Therefore, there is a quantitative relationship between a subjective aesthetic experience and the objectively identifiable intensity of change in blood flow and therefore of activity in a given specific area of the brain. Now, if you have stimuli which are revolting and not ugly, not beautiful, then of course the activity is elsewhere. In fact, it is in this case, but not in all cases. I think Samuel will be talking about that. I'm talking of ugly, more than ugly, sort of revolting stimuli. The activity is in the amygdala, but again, it's quantifiable. Here, the ugly stimuli are much more intense, or the revolting stimuli, I should say, are much more intense in activating this region than those experienced as beautiful. So there is a quantifiable relationship between the declared intensity of the experience of beauty and the observable change in blood flow and therefore of activity. In other words, the more intensely you feel something is beautiful and you grade it very highly, the more intense will be the blood flow in the medial orbital frontal cortex. All of which leads to this, that there is a selection. There's a selection occurring in some part of the brain which determines that signals are sent to one destination or another. So there are parts of the brain. Now, this is a horizontal section through the brain. At the very back here, I hope it does not change. At the very back here is the visual cortex. This is a representation of specialized areas. In this case, specialized areas of the visual brain for perceiving bodies. And we know that there are such areas in the brain which are specialized for perceiving bodies or which are critical for perceiving bodies. And these are two other areas here in yellow and in blue. The blue one here, turquoise rather, is the medial orbital frontal cortex. When people look at something they qualify as beautiful, when they look at something beautiful, the activity is channeled to the medial orbital frontal cortex. When they look at something which they experience as disgusting, then the activity is shared between these areas, but is shared between these areas, but then is channeled to this one. In other words, a selection occurs somewhere along here, which sends the signals to this area or to that area. And therein, the selection process, Samuel will talk about it in a moment, but there lies a very, very important principle. Francis Crick and Ted Jones, many years ago, wrote an article in Nature in which they lamented the fact that we know very little about the anatomy of the human brain, the anatomical connection of the human brain. And of course, most people assume that these anatomical connections can be traced by injecting one area with a tracer or making a lesion or looking at the myelination and so on. We would like to propose, on the basis of these studies, but also on many other studies which have not explicitly said so, that experience constitutes a new anatomical tool for tracing connections in the brain, because the connections between the visual cortex and medial orbital frontal cortex and specific parts of the visual cortex, specific parts of the medial orbital frontal cortex, only become evident when you have an experience, an aesthetic experience. So experiences become an anatomical tool for investigating connections in the brain. Now, let me just say that the making that explicit belongs to us, but the idea, the work that led to that explicit statement about experience-dependent anatomical pathways in the brain is based on many, many other papers that have been published, which have shown that certain pathways become evident only when you have certain experiences. But they did not use that as to describe a new anatomical tool, which I'm doing for you right now. Now, when you talk about selection, according to what is the selection made? The Greeks thought that you could construct the perfect human body, Polyclitus and Myron and various others. You could construct a very beautiful, very perfect human body by mathematical formulations. And they built, this is one of the examples. And of course, they argued endlessly about what constitutes a beautiful body and a beautiful face, the proportions, the relations, and so on and so forth. The golden ratio, of course, always comes up. And the answer is that there are certain requirements for perceiving something as beautiful in a face. For example, the eyes and the nose and the mouth have got to have the precise relationships to each other. They've got to be in precise proportions to each other, and so on. But there is another feature, an ineffable feature, which adds to the beauty of a stimulus. In other words, what I'm trying to say is that you can have all these right proportions and the right distances and right everything else and still not have a beautiful face. There is something undescribable or undescribed so far about what really constitutes a beautiful face. Whatever that is, I think it's reflected in the experience-dependent anatomical connections, which Samuel will talk about. But what I want to do now is to tell you that these relationships have to be obeyed, and if you disobey them, there is no way in which you can find a face as beautiful. So the selection must be made, the selection between where to send the signals in the case of beautiful face must be made on the basis of having a face that has got all the right relationships, plus that ineffable quality which we still do not know about, but which we think is reflected in some anatomically demonstrable property, which Samuel will talk about. Now, one great painter of the last century was Francis Bacon. Francis Bacon, who was a descendant of the Francis Bacon, the scientist. Francis Bacon said, "I want to give me a shock." And I want you to listen to him saying that his whole aim in painting was to give a visual shock. And I want to then show you how he went about it. So here is him talking. So he just wanted, his aim was to give a visual shock. And he said that the painting that he made were really not things that intelligence and intellect can make. Listen to him again. I've made images the intellect can never make. In other words, what he's saying is that they come from sort of something more primitive, more primordial. So what did he do? He painted, he traduced and damaged the faces that he painted. So here is his picture of a woman who he thought was a very beautiful woman, Elizabeth Hawthorne, who used to run a bar he used to go to often. You see, her lips are contorted. The relationship between the nose and the eyes is wrong. But and that's why he gave a shock, you see. And here is his boyfriend, his lover, George Dwyer. It is a deeply shocking thing. I mean, you know, the chin is partly here, the chin is partly here, partly here. There's a big gash here, which disfigures. That's what he liked. He liked to disfigure faces, but he never disfigured objects. Right? because there's a difference, as Samuel will tell you, between biological beauty and artificial beauty. He disfigured bodies and he disfigured faces, but he never disfigured um, objects. Objects are perfectly identifiable. And here's another painting of someone who is severely disfigured, but the deck chair is quite normal, except perhaps for the absence of a leg. So you can't have something as beautiful without having certain proportions in relationships. And you know that if you traduce these proportions and relationships, if you damage those relationships, then a face cannot be considered to be beautiful in any country, in any race, or in any cultural grouping. The brain has got, you have to obey these rules, because the brain, I think, has got a template of what constitutes a beautiful face, and it is on the basis of that template that the selection is made. So I'm now going to define for you beauty in neurobiological terms. Beauty is the state when the sensory areas of the brain, say the visual areas or the musical auditory areas, are co-active with the medial orbitofrontal cortex. When the two areas are co-active simultaneously in time, then you are experiencing beauty. And that's a very precise, in fact, I think it's probably the most precise definition of beauty which we ever have. And what that co-activation entails is something which Samuel, who, by the way, has just obtained his PhD, so I think you need to congratulate him for that, will tell you about. So let's move on to the next slide. Now, finally, I want to talk about the experience of mathematical beauty, which is, of course, the most extreme form of beauty that is dependent upon culture and learning. So, you cannot go to people in the corridor of university college and ask them to look at a formula and tell you whether it's beautiful or not, because they don't speak the language of mathematics. To do an experiment on mathematical beauty, you have to get mathematicians who know the language of mathematics. And it took us a long time to do that. And I did this with Sir Michael Atiyah, who was one of the foremost mathematicians of the last century. And it turns out mathematicians are very difficult people. They are very fussy about what formula you can accept, because they want them to be very abstract. They want not to have any sort of spatial connotation or physical connotation or any connotation of anything besides a mathematical connotation. And so you do the experiment in the same way. This time, however, you get people who are postgraduate or postdoctorals in mathematics, and you show them 60 mathematical formulae and ask them to rate these formulae on a scale of 1 to 10 or 1 to 20, according to how beautiful they experience these mathematical formulae to be. And then they come back to the scanner and they re-rate them while looking at them, and we determine which areas of the brain are active. And to give you an example, the formula that was regarded by everyone as being very beautiful is Leonard Euler's identity formula, which links 5 mathematical constants with 3 basic arithmetic operations, each occurring once. This has been compared by Michael Atiyah, who was my collaborator on this, to the soliloquy from Shakespeare's Hamlet. And it is surprising that the mathematicians were very, very emotional when they saw this formula. And some of them were really in tears, and others said they had butterflies in their stomachs. And so it was an emotional experience apart from being an aesthetic one. Whereas the next one, which is Srinivasa Ramanujan's formula of equation expressing the inverse value of pi as an infinite sum, was judged by most to be ugly. Now, some mathematicians have written to me since the publication of this paper that really this is not fair, because this Ramanujan experiment is an important one, but that is to miss the point. The experiment, the subjects, when they came to do the experiment, experienced it as not beautiful, and that is the conclusion. This is not for that experiment. This is quite an important thing to remember. These experiments are valid for when they are done. And so let us look at what happens in the brain when people experience mathematical beauty. And the answer is you get the identical same area of the brain here, medial orbital frontal cortex, that's active, and the activity in that area is parametrically related. Let's say it's proportional to the declared intensity of the experience of mathematical beauty. So this now takes me to the last point I would like to make. First of all, I want to make a general point about the fact that this paper was rejected by Nature and Science because they said it was not of general enough interest, so they did not even review it. Let me tell you, since its publication in 2014, it has been viewed over 190,000 times, including in countries like Libya and Syria and Sudan and war-torn countries. So I have not the slightest interest in the opinions of the editors of Nature or Science about what is of scientific interest to people in the world. But let us ask the question, what does mathematical beauty consist of? That's the question that Immanuel Kant, the German philosopher, asked. And his answer was, it consists of the fact that it makes sense. But he did not ask the next question, which is the important question, which I'm going to ask now. Sense to what? And I'd like to say that it makes sense to the logical deductive system of the brain, which is similar in all of us. And therefore, mathematical beauty comes under the category of biological beauty. And it is through the mathematical beauty that you begin to understand various strange phenomena about the world. I think it was, what's his name? The next slide, yes. Paul Dirac is one of the great physicists, one of the greatest English physicists since Newton, who put forward the principle of mathematical beauty. Paul Dirac wrote, and I shall quote him, he said that the theory of relativity by Einstein imported beauty into mathematics to an unprecedented level. Before his time, the truthfulness of the mathematical formulae was determined by whether it was simple or not, by simplicity. Whereas since the publication of the theory of relativity, the truthfulness must be determined by the beauty of a formula. And it is through the beauty of mathematical formulae that physicists and mathematicians have actually been able to understand much about the universe. I think it's little known that, for example, black holes, the expansion of the universe, dark energy, dark matter, and much else besides, have been apprehended before experiments were done to prove them. And they were apprehended because they were thought, the formulae leading to them were thought to be extremely beautiful. So mathematical beauty, which Plato regarded as the highest form of beauty, has its place in understanding the universe, precisely the reason for which Plato thought it was the highest form of beauty, because he said it's through mathematical beauty that you understand the universe. So finally, I'm going to end up with a brief story about Hermann Weyl and Paul Dirac. Actually, about Hermann Weyl. Hermann Weyl was a great mathematician, and he said, whenever I work, I try to reconcile truth with beauty. But if I have to choose between the two, I always choose beauty, which is a strange way of putting it, because that's separating truth from beauty. Anyway, he worked for 10 years or so to reconcile the electromagnetism of James Clerk Maxwell with Einstein's theory of relativity, and came up with a formula which he thought was very beautiful. And he sent it to be published, and it was reviewed by Einstein, who said, you can't publish this because it's against all the known facts. But Hermann Weyl's reply was, yes, maybe against all the known facts, but it is beautiful, so publish it. So they published it, and after publication, it turned out that all these formulations were correct and did not require any correction. And this is a story related to me by Michael Atiyeh himself. So it perhaps exemplifies the triumph of beauty over truth, but only if you believe that truth and beauty are different. I would prefer to end by quoting John Keats, the young English poet, who said, "Beauty is truth, truth beauty, that is all you know and all you need to know." And with that, I'll pass on to Samuel Rasche.
All right. I just need to switch out the presentation. Wait. Sorry, give me 1 second. Okay, right. So in this, well, first of all, thank you very much, Professor Zeki, for that wonderful presentation. I want to take it a step further and look at what this activity really means that becomes apparent with beauty. So I want to look at specific patterns of activity that we see that emerge with aesthetic experiences. But first, let me briefly summarize what we have just learned. And that is that with beauty, when you experience beauty, there's increased activity in specific sensory areas. Now, which sensory area becomes active depends on the stimulus type. So it depends on the stimulus that you are seeing. But we have also seen that there's increased activity in field A1 of the medial orbitofrontal cortex with beauty. And this is regardless of the source. Any type of stimulus that is considered beautiful by the subject will activate this region of the brain. And we have therefore defined beauty in neurobiological terms as the co-activations of sensory areas and field A1 of the medial orbitofrontal cortex. So again, let's take a brief look at 3 different studies. Here we have the activity related to facial beauty, mathematical beauty, and beauty derived from abstract paintings, so more abstract beauty. And we can see that they activate different regions of the brain, but we can look at what region they all have in common. And that is, again, this region of the brain, field A1 of the medial orbitofrontal cortex. Now, these studies have all been done with the so-called univariate approach. So Professor Zeki briefly explained how fMRI works. So it's about measuring the blood flow. More active cells require more blood, more oxygenated blood. And we can measure this contrast between oxygenated blood and deoxygenated blood with fMRI. So we measure this activity in so-called voxels of the brain. So what happens is that we divide the brain into these tiny little cubes that all represent a little piece of brain tissue. And then within this cube, we try to estimate or predict the signal. So we want to know how well are we at explaining the signal in this particular cube. And if we are able to explain the signal, we can say that, okay, thanks to introducing my stimulus in this particular task, we see there's increased activity in this or that voxel or cube. So each voxel is assessed independently. Now, there's one issue with this. It's the issue of representation. It doesn't tell us how the information is represented in a particular brain area. Now, there's an alternative approach, the so-called multivariate approach, which actually looks precisely at this. So what you do is you look at a group of these voxels at the same time. So you look at the area at the same time, and you try to see how is the activity in that area arranged? How is it distributed over the group of voxels? So we're specifically asking, what does the pattern of activity look like? And one of these approaches is the so-called RSA approach, the representational similarity approach. And what we do is we assess each stimulus independently. So let's say we're looking at faces. We look at each face independently, and we try to look at a group of voxels at the same time. So imagine all these cubes here, all these squares, I mean, are a voxel. And we can see that this face, for example, activates these voxels, and this phase activates these voxels to this extent. Now we can already tell that they have a pretty similar pattern of activity because they activate each voxel to a similar extent. But what we can do next is quantify this similarity. So we can use a measure to see how similar the two patterns are between these two phases. So we can simply just take the correlation between the two. And this way we have a metric, we measure really how similar two activation patterns are. So we can do this for all the phases that we have, and then we can build a matrix with the correlations of each phase. Now, of course, the same phase is going to have the same correlation, so the similarity there is 0. But here in this particular hypothetical area, we can already see that this phase and this phase have a more similar pattern of activity than this phase and a strawberry has, or this phase and the butterfly has. So for this hypothetical area, we can say that phases have a similar pattern of activity. Now we can do the same thing for beauty. So what we can do is we can sort all the beautiful phases together and also all the not beautiful phases together and say, we expect that all the beautiful phases have a similar pattern, whereas the not beautiful phases do not have a similar pattern. And also the very beautiful phases and not beautiful phases do not share a pattern. So this is really a perfect scenario where you see that it's only the very beautiful phases that activate a particular brain area in a similar way. Now, if we take a random region that we do not expect to be engaged with facial beauty, such as, for example, the auditory cortex, we wouldn't expect to find such a pattern. And indeed, as we can see here, the matrix just becomes a noisy blob, really. And we can see that there's no distinction between the very beautiful ones and the not beautiful ones. But what we do find is that there is such a pattern for beautiful faces in the medial orbitofrontal cortex, the region that we saw earlier that is so important for the processing of beauty. And we also find a specific pattern of activity in the cuneus and the fusiform face area and the occipital face area. And these are all areas that are very important for face processing. Now, the pattern may not be so obvious in these matrices that you see here, but we compare this to our model, and this way we can assess how significant it is and whether there is a significant pattern. So from this, what we find is that beautiful faces evoke a similar pattern of activity in the face perceptive areas and in the medial orbitofrontal cortex. So what this is telling us is that the face areas are not just merely active when they see a face. They can also detect when the face is beautiful. And this is represented by a distinct pattern of activity. So this is where we go back to what Professor called the ineffable quality. We believe that this ineffable quality of beauty is represented in the brain by a specific pattern of activity. And we can also take this further and say that this pattern of activity enables the co-activation with the medial orbitofrontal cortex. So there we have our experience-dependent connection. Now, we don't know anything about the directionality, whether it is that the sensory areas engage the medial orbitofrontal cortex or vice versa, but at least we can say that the sensory areas take part in this selective process in sort of detecting whether a face is beautiful or not. Now, faces, of course, are a biological stimulus. And in neuroesthetics, a theory that is proposed by Professor Zeki is that we can divide sensory experiences into two categories, really, into the biological category and into the artifactual category. And the biological category consists of things that are abundant in nature, such as color categories or faces. And these are thought to be inherited from birth or very rapidly acquired after birth. And they're also much more resistant to peer opinion. So for example, if I find a face very beautiful, you tell me, no, that's not a beautiful face, I'm not very likely to change my opinion on that. So another thing that the biological stimuli have in common is also that we believe that they're more universally present. People in generally seem to agree what a beautiful face is. Now, with the artifactual category, we refer to objects that are made through human agency. Think, for example, of buildings or cars, of abstract paintings. And these are acquired throughout life and are much more or much less resistant to change. If someone were to tell me, if I find, for example, an abstract painting beautiful and someone were to tell me this is not a beautiful painting, I'm more likely to change my opinion about the painting than I am, for example, with faces. So we say that this is also less likely to be universally present. So people's opinion on artifactual stimuli are much more subjective. Now, this distinction is very clear, becomes very clear from these experiments that we do on beauty, where we have subjects rate all these different faces and, for example, abstract paintings. So let's first look at faces that belongs to the biological category, which we see here. So here we have a graph of the intersubject agreement, which means that we take every single subject's rating and we correlate that to the ratings of all the other subjects. So if the correlation is 1, it means that 2 subjects gave the exact ratings to all the faces they were presented with, and they were presented with 120 faces. So what we can see here is that there's a very high correlation, which means that subjects in generally agree on which faces are beautiful and which ones are not beautiful. And this is also emphasized by the right panel here. Here we have the top 10 best rated faces and the 10 worst rated faces. And we can see that the very best rated faces on average do not receive any low scores. They only receive a score of 4 or higher. So a score of 1 means that a subject doesn't find it beautiful at all. A score of 7 means that they find it very beautiful. And we see that there's very little variance. Everybody finds these faces beautiful. Whereas when we look at the worst rated face, nobody gave it a score higher than 3. So everybody found this face not beautiful. Now, if we contrast this to artifactual beauties, especially beauty derived from abstract art, we see a very different trend. So here we can see that the between or the inter-subject correlation is only 0.16, meaning that subjects did not agree on which paintings are beautiful and which ones are not. We can even see that some correlations go negative, meaning that what one subject found beautiful, the other did not find beautiful. And this point is also emphasized here by the right panel. So if we look at the very best rated painting on average, it still receives scores as low as 1. And also the worst rated paintings still receive high scores. So we can see that there's much more variance. And from this, we can conclude that artifactual beauty is much more subjective than biological beauty is. We therefore say that the beauty of faces, at least, is universal. Now, this naturally leads to the question of whether there's also these activity patterns in abstract art, given that there is this distinction between artifactual and biological beauty. And yes, indeed, we find that there are also specific patterns with abstract art. This time they are in other sensory areas. They're in sensory areas that are related to the processing of color and form. But interestingly, we do not find patterns in the mediorbital frontal cortex. So as we saw earlier, when you are experiencing beauty in abstract art, there is increased activity in this region, just as with all the other types of beauty, but we do not find a specific pattern of activity in this region. So this could possibly be due to this distinction between biological and artifactual stimuli, but that's what still requires more further research to really conclude. Now, so far we have discussed beauty, of course, but in neuroaesthetics, we're also interested in other aesthetic experiences, for example, that of ugliness. And ugliness is often regarded to be the opposite of beauty, but it may as well be a category on its own. And this has led to many philosophical debates, and also why some studies choose to not include ugliness on the scale that they use when they have subjects rate all these stimuli. So there is a philosophical question of whether ugliness and beauty are on the same continuum or two separate categories. And this is also stemmed from the idea that ugliness has specific components attached to it. It's often related to dislike or disgust, and it may also serve as a sort of warning signal of possible threat of disease. So one way of addressing this philosophical question is, again, by using neurobiology. And we conjectured that if they indeed are two separate categories, we would also expect that a different neural network is involved with the two experiences. Whereas if they're from the same category and just two extremes within that same category, we would expect that the same neural network is involved with the two experiences, but that there's just a different modulation of the activity within that network. So to test this idea, we set up a very simple experiment, very similar to all the other studies done on beauty, but this time we're not asking about the beauty, but we're asking about the ugliness. So we're treating ugliness as a category on its own. And so the scale ranges from 1 to 7. 1 means that you find a stimulus not ugly at all, and 7 means you find a stimulus very ugly. And we just showed simple faces. So subjects perform this task, and then we measure their brain activity. And we find that when there's increasing levels of ugliness, so when a subject finds a stimulus uglier, we do not find increased activity anywhere in the brain. But interestingly, with decreasing levels of ugliness, so when the subject finds a face less ugly, we see that there's increased activity in beauty-related areas, specifically in this part of the brain, a more posterior part of the medial orbitofrontal cortex. But we have seen that this is also related to beauty, for example, with moral beauty. So this region becomes, there's increased activity in this region with less ugliness. So this already gives us an indication that the same neural network appears to be involved. But we can also look at patterns of activity in response to ugliness. And so we looked at whether the ugly faces have a specific pattern of activity. And indeed, they do have specific patterns of activity. Again, in the same regions as with beauty. So you may remember from the previous slide that with beauty, we had specific patterns in face perceptive areas, such as the occipital face area and the fusiform face area, and also in the precuneus. And we found specific patterns of activity in field A1 of the medial orbitofrontal cortex. Now, importantly, the two patterns are different. So what we're seeing is that both beautiful faces and the ugly faces engage the same areas, but they have a different distribution of the activity in these areas. So from this, we can conclude that there's really no region that shows increased activity with increasing levels of ugliness. But what we do see is that with decreasing levels of ugliness, we see increased activity in beauty-related areas. And both ugly faces and beautiful faces elicit specific activity patterns in the sensory areas and also in field A1 of the medial orbitofrontal cortex. So again, we can conclude that aesthetic experiences, at least when it comes to facial beauty, is due to the co-activations of sensory areas, of face perceptive areas, and field A1 of the medial orbitofrontal cortex, but then with different levels of activity and with a different distribution of activity, depending on the experience you're having. So whether it is beautiful or ugly. And based on this, we can conclude that ugliness and beauty lie on the same continuum. So again, we're using here neurobiology to try to answer a philosophical question, just as we did earlier on with Clive Bell's question. And this way we can hopefully help the humanities in further progressing into the field of aesthetics. And that's it. Thank you very much.
Thank you very much for this amazing presentation. It was wonderful. And if you have time, also, we would like to ask a few questions.
Yes, absolutely. Professor Zeki is also here to answer any question.
Okay, I will keep reading. First question is, first of all, thank you for your precious insights. As a master's student in cognitive science, I am interested in musical aesthetic experiences. However, even though you mentioned that aesthetic experiences can be quantifiable, it seems like there are many constraints to quantify these perceived and felt experiences, given the fact that subjectivity, namely autobiographical memory, plays a huge role. How can we overcome this issue? Even though I completely agree with your point of view, as I dive deep in the literature, I am starting to having my concerns on how exactly should I create an experimental design to measure the aesthetic experiences because of the so-called complexity of subjectivity?
Right. Well, now the simplest way of ending a nice conversation at dinner is for someone about beauty, is for someone to say, "Oh, well, it's all subjective anyway," but it is not. I mean, a very beautiful face, be that of a male or a female, in Japan will be considered to be very beautiful in Turkey or in England, and vice versa. So, if you were to take a third person, an observer, and collect, say, 10,000 people from around the world and ask and show them faces, you would find, as Samuel just showed you, you'd find a surprising degree of agreement about what constitutes a beautiful face. So that a third person, the outside observer, will have to say, "Oh, well, look here. This is quite an objective. I mean, most people agree on this." On the other hand, if you were to take an architectural sort of building, I think you'd find significant disagreements, and the outside observer will tell you, "Well, this is subjective because people are not in agreement." So it is wrong to think that all aesthetic experiences are subjective. Many of them are very, very, very objective. And I showed you the example of what happens if you deface a face, if you damage a face, then people find it horrible. They cannot. There's no way in which anyone anywhere in the world is going to find somebody with one eye here and another eye on the cheek as beautiful. It's not going to happen. Now, let me just go on to the question of whatever it is, whether you consider it to be subjective or objective. The fact is that I can tell you, if you show me a brain in which a sensory area, let us say the face area, the orbital front, the occipital face area, the physical face area, are active, are coactive with the medial orbital frontal cortex, and a pattern emerges in them, I can tell that that person has had an aesthetic experience. Now, if then you show me the brain of the same person, this time also with the face areas and the medial orbital frontal cortex coactive, but with a different pattern of activity, then I can tell you that these two experiences are different. Now, that's as objective as you can get with a subjective experience.
Yeah. And I want to add one thing to that. So indeed, as Professor points out correctly, there is this objectivity in these experiences. But also in the end, what we're doing in the scanner, what we're aiming at is to capture the experience of beauty. So subjects give their own rating. So this person doesn't have to worry about whether it is subjective or not, because in the end, what matters is that you create this condition in which you have an experience of beauty and you compare that to a condition in which you do not have that experience. Now, whether everybody agrees on it, it's not necessary, but that's why that's the reason we take everybody's own ratings when we do these comparisons in the scanner.
So can we in response to that question, because it's a very important question, really, summarize what is subjective and what is objective in all these experiments? There's one thing which is really objective in all of these experiments, is that whenever the sensory areas and the medial orbital frontal cortex are coactive and a pattern emerges in them, then people are having an aesthetic experience. That is an objective fact. When they are having an experience of something beautiful, and when they're having experienced something ugly, the sensory areas and the medial orbital frontal cortex are all again coactive, but with different patterns, and that is a fact. There is considerable agreement between subjects of different nationalities, different ethnic groupings, and different cultural backgrounds about whether a face or certain biological categories like a body is beautiful, and that is a fact. And you don't need really science to establish this fact. After all, the catwalk models are all based on the fact that we find the same people attractive. These are all objective. What is subjective is the artifactual beauty is not everybody classifies not everybody experiences different types of artifactual beauty as with the same degree of beauty or intensity. But whenever they do, then they have coactivity in the medial orbital frontal cortex and sensory areas with a pattern emerging in them. So we have come a long, long way, really, a very long way. Actually, I'm surprised now just talking to you how long a way we have come in objectifying what is traditionally being regarded a very subjective experience.
Mm-hmm. Thank you very much for your detailed explanation. And the next question is it possible to hypothesize a direct relation between auditory beauty and perception of poetry?
Sorry, could you repeat that question?
A relation between auditory beauty and poetry.
And perception of poetry.
In perception of, that's an interesting question. So to be brief, we have never conducted such a study. Of course, if they both elicit an experience of beauty, we would expect that they both engage field A1 of the medial orbital frontal cortex. So in that sense, that is the commonality between the two. Now, of course, you're still comparing an auditory stimulus to a visual one, so they will definitely have distinct patterns of activations in the brain or engage a distinct network in the brain. But at least in terms of if that's what you're after about the beauty of it, we can say yes, they have a commonality, and that is that they both activate field A1 of the medial orbital frontal cortex.
There is. I mean, we know that. Look, there's a good sort of powerful interaction between different kinds of beauty. I mean, you see it in movies all the time when people are sharing in a movie. There's a sad scene. There's a sort of music which enhances the experience of beauty. But there's something I'd like to quote to you from Ezra Pound. Ezra Pound was a poet, and he was the great mentor of T.S. Eliot, who's the greatest of English poets of the last century. He said that poetry begins to atrophy when it moves too far from the music, and music begins to atrophy when it's too far from the dance, which is not to say that all good music is dance music or all dance music is good music. That is a very nice summary of the strong relationship between different aesthetic experiences.
Thank you very much for your explanation. And the next question is, have you tried to present visual and auditory stimuli at the same time in your study? Do you think that presenting aesthetically perceived stimuli from different modalities at the same time causes excessive activation in the brain region you mentioned?
Um, we did that, but the results were not very satisfactory, so we never published them. And because it was done some years ago, I've forgotten the results. But they were not very satisfactory.
Mhm.
And the next question is, some critics argue that the methods used in neuroaesthetics, such as you mentioned fMRI studies, may simplify the nature of aesthetic experiences. How valid are these methods in truly capturing the essence of beauty?
They are by misguided people. These are the enemies of progress. Of course, in 30 years' time, in 100 years' time, these experiments will come to be regarded as trivial and oversimplistic when new techniques become developed, just as the physics, gravitational physics, is on its own is regarded to be trivial, well, not trivial, but incomplete without quantum mechanics. I have heard this argument, and I'm very impatient with it. I think because it is like a professor once said to me about mathematical beauty. He said, "Well, isn't that to be expected?" No, sir, it's of course not to be expected. You have to do the experiment. Now, these are the tools that are presently available. When better tools become available, then we will use them, or our successors will use them. But let's look at the question. 2,500 years of argument about the nature of beauty without a successful conclusion, and 10 works with imaging, and you have got a definition of beauty which is very precise. What is that to be answered there?
Mhm.
Thank you very much. And the next question is, how do aesthetic preferences change with age, and what are the neural underpinnings of these changes?
Mm. Yes, I mean, so this brings us back to that distinction between biological and artifactual beauty. Of course, your opinions can change and it can happen for any category, but it's much more likely to happen for artifactual stimuli. So, for example, let's take abstract art. Um, you have a certain preference at a young age, but then you learn a lot about certain artists and certain art styles, and that may very well change your opinion about certain pieces of art. Now, with the biological category, it's much less likely that your opinion will change. So if you find a certain face beautiful, it is likely that you will always find this beautiful. And whereas the other ones that you find ugly, it's likely that you will continue to consider this ugly. So that's why we make this distinction between the two. And we say that one is more universal and also more inherited, whereas the other one is less stable, really. Now, we haven't really looked at, I think, in the progression over age, at least not to the neural underpinnings. But in the end, what we're looking at is really at the experience of beauty. So if we were to do an experiment with young people and have them rate the beauty of certain stimuli, and then do that same experiment with those same people, but 20 years later, if they still experience that beauty in those stimuli, we will again find that there's activity in the sensory areas and the medial orbitofrontal cortex. So in that sense, we wouldn't expect different neural mechanisms to be involved, unless of course you're no longer experiencing the beauty. Then of course the coactivity with the medial orbitofrontal cortex also disappears. So yeah.
Thank you very much. And the next question is, to what extent do neuroaesthetic findings challenge the concept of free will, particularly in the context of how our brain responds to art?
Sorry, how it challenges the concept of
free will.
Free will.
Well, I'm not myself a great believer in free will. I think we are constrained very much by the organization of our brains, and of course there is. I mean, there is some leeway. There is some leeway. There is culture. There is the cultural background in which one is brought up. But I don't believe that we have free will in the sense that we are completely free. I mean, when you think about it, it's an interesting question. I have not thought about it in this context, but when you think about it, you don't have a free will to experience a very beautiful face as not beautiful because you want to say, I want to experience it as not beautiful. You can't do that. Nor can you take a very ugly face and experience it very, very beautiful. It's not going to be possible. So, that shows you how limited your free will is. Now, as you may know, I have done a lot of work on color vision, and I can tell you till the cows come home that this green leaf is reflecting more red light, therefore it should be red. But you have no free will to see it as red. It doesn't happen.
Okay, thank you very much. And the next question is, to what extent is artistic talent a result of innate neural characteristic versus environmental influences and training?
What?
Artistic development. So if it's I think with any skill really, there's always this debate between nature and nurture. Just also with artistic talent, I think people have a certain propensity, but of course it also requires hours and hours and years of training, and it's usually the combination of both that leads to a great artist. Now I don't want to I'm not I don't feel confident in commenting on whether being born with it or the training aspect is more important than the other. I wouldn't be able to say that, no.
Well, I mean, it's quite clear. For example, Mozart will start writing sonatas at the age of 3 or 4. That this must have been innate, but I think most humans have got to learn it to varying degrees. I mean, you see, you can do whatever you want. You can send me to the most wonderful schools and the most expensive universities around the world. There's nothing you can do that will enable me to learn and mathematics. I am hopeless at mathematics. I mean, my parents tried very hard to teach me the piano, and I was very resistant. I regret it now, but I was resistant, and I don't think I've got a musical facility. I have one for listening to music, but not one for playing or creating it. So there is an innate, I think.
Thank you very much. And next question is, how would you explain the importance of the field of neuroaesthetics in academic and industrial terms?
Right. Well, I think neuroaesthetics has had major impact. I mean, one of the things we can look at, for example, is it's important to surround us. So beauty is very important for well-being, and if we surround ourselves with beautiful things, I think that will also generate a sort of community of well-being. And we can see that more and more ideas are proposed about using beauty to enhance also treatment or healthcare facilities to make it more agreeable for the patients and possibly improve their conditions. So in that sense, I believe that neuroaesthetics is very important. Then in the academic aspect, of course, just as studying any cognitive ability, this studying beauty is of major importance because it explains to us how the brain works and what brain areas are involved in certain experiences and what allows us to feel such a wonderful experience. Really, I think everybody would agree that beauty is a pleasurable experience.
May I say something about that? I think you see, the medial orbital frontal cortex is a large part of the brain. And it is not just sitting there idly, it needs to be stimulated. And I mean, it is the same part of the brain that is stimulated with reward and with pleasure. And if you take Sigmund Freud and before him Fechner and before him the founder of my college here, Jeremy Bentham, said that the whole purpose of life is the pursuit of the pleasure principle. So that means that the whole purpose of life is really stimulating the medial orbital frontal cortex. It's extremely, extremely important. living in beautiful surroundings. I think we don't have cultured enough cultural ministers to understand that living in beautiful surrounding is a big reinforcement for people. And it is quite interesting that the medial orbitofrontal cortex is the same as the field A1, is the same part of the brain that's active when you experience reward, and beauty is rewarding, when you experience pleasure, and beauty is pleasurable, and when you experience desire, and beauty is desirable. Or beautiful things are desirable. So it is from the point of view of um, daily life, from the point of view of understanding the brain, from the point of view of understanding the pursuit of the brain, the pleasure principle, it's extremely important. From the academic point of view, it's another issue which is quite interesting. I think for many years, people thought that this is an area that belongs to the humanities. And the humanities, may I say, people in the humanities have been distinctly hostile. Not all of them, but some of them have been distinctly hostile to the idea that that we were intruding into their field. But we were not intruding in their field. We were not asking what is beauty. We were asking what are the brain mechanisms that are engaged during the experience of beauty. So neuroaesthetics is more really a study of the brain than of beauty, right? But it has got important consequences. And if people in the philosophy of aesthetics choose to ignore it, that's fine and all right by us. But it should have an important consequence for their theorizing, because as far as I know, and I could be wrong because I don't know all that literature very well, as far as I know, nobody has been able to give as precise a definition of beauty as I have. And nobody has been able to say, Clive Bell at least admit that, what is common to all that we experience is beautiful. Nobody has been able to tell you until recently that the experience, so subjective experience as beauty could be quantifiable. Nobody has been able to say that the same parts of the brain will be excited by the experience of something really abstract, namely mathematical beauty, and by painting. So these are all very considerable achievements if people want to think about it in that way. I think myself that perhaps the much more important would be, I hope, would be the effect on social policy in understanding that the pursuit of beauty is good for society. And it should be the planners of buildings and of urban sites should pay considerable attention to beauty. I mean, they've got great difficulties because they've got to question of money. There's a Turkish gentleman whom I knew who was an architect, actually, a most interesting person. He told me that he was approached by a rich man in Istanbul and asked to provide him with a nice, beautiful house overlooking the Bosphorus. And he was continually complaining about, I want more, I want this, and I want that, and I want something like something like Zinan, all right, what Zinan would construct. And my friend said to him, well, you should consider who Zinan's patron was. You are not as rich as that. But you see, Zinan's patrons were able to pay for having beautiful buildings, which till today, I mean, the Sultanahmet Mosque and Topkapi, and all these are beautiful places. People pay to go and see them. Very important.
Thank you very much. And the last question is, how do neurological and psychiatric conditions influence aesthetic perception? And can studying these conditions provide insight into the neural basis of normative aesthetic experiences?
Now, it's an interesting question that we also thought about ourselves. There hasn't been, of course, now that we know that field A1 of the medial orbitofrontal cortex is so important in the perception of beauty, you would expect that if this region is damaged, you also lose that that ability to experience beauty, or at least to judge something as beautiful. So in this sense, of course, case studies would be very important. Now, there hasn't been such studies. What we have seen, however, are cases of artists and how their art changes after acquiring dementia that also affects frontal parts of the brain. And we see that their art becomes much more, let's say, horrific, or so they start drawing scarier faces. Also, they become more repetitive in their actions. So it, of course, influences the type of art that you're making after brain damage. But this is a very unexplored territory, and I believe that there's much to gain here. And I would love to conduct such a study with patients to see how their concept of beauty has changed. Yeah.
Thank you very much for all your answers. We are truly grateful for this amazing presentation, and we want to present to you a certificate.
Oh, thank you very much.
We are really grateful. We are truly honored and
Nice.
privileged to host you here today. It was really informative, and we are truly glad. And also, if it is okay for you, we want to take a picture right now with the participants.
Yes.
As a memory. So dear participants, if you're available, you can turn on your cameras right now.
You want to turn on your camera?
Yeah.
Oh, yeah.
I'm so sorry, there's a problem in my laptop. So, okay. Okay, thank you very much for everything, and thank you for accepting our offer. You're really kind. Thank you very much for everything.
Thank you very much
Thank
for
you.
having us, and I wish you all very good futures.
Thank you very much, and thank you for contributing our neuroscience community. We are a student committee in Ankara University, and we are we have a lot of events. We have congress and seminars, and we will be truly delighted to see you in one of them.
I hope so.
If
Thank
you
you.
ever come to Turkey.
Thank you.
Thank you very much.
Goodbye.
Thank you. Bye-bye.
Very much.